And finally, our last lesson involves the two organ systems that allow our movement and allow our voluntary activity. And those are the muscular system and the skeletal system. First we have the muscular system. Now the muscular system is the thing that allows movement. A muscle, generally speaking, is a tissue composed of cells that are capable of contracting, which means squeezing together, tightening up, which causes movement, thereby moving part of the body. The three types of muscle that we have in human beings and that are in vertebrates in general, animals that have backbones in general, are skeletal muscles, which are attached to bones that allow us to move. There are cardiac muscles, which are heart muscles that allows our heart to contract and pump blood throughout the body. And then there are smooth muscles, which are associated with involuntary activity, such as breathing, moving blood around, etc. Let's take a look at some of the skeletal muscles in general. First are the leg muscles. Leg muscles are, well, the leg muscles contract when lifting heavy objects is determined by the frequency of action potential and number of muscle fibers stimulated. You've got millions of these little muscle cells, and what they're attached to is they're attached to your skeleton. They're attached to your bone. The way they move is when they contract, in other words, they squeeze together, it pulls back, and when they relax, it moves back in the other direction. So when you can contract the muscles behind your leg to lift your leg up, and you can relax them to put them back down. The largest motor units in all the human muscles are the leg muscles. Those are our well, maybe not the strongest. I think they say that the jaw muscles are the strongest muscles, but certainly the largest and the thing that carries the most weight, literally. The leg muscle fibers, there are fast twitch muscle fibers, which are able to move quickly, and these are things that are built up in runners and sprinters. Then there are slow twitch fibers, which have more mitochondria because they need more energy, they need more respiration. Remember, mitochondria does the respiration, and they contract with less power than fast twitch fibers. And these are built up by long distance runners. Basically, the idea is that both of these are necessary. The slow twitch fibers are built more for long-term consistency, whereas fast twitch muscle fibers, they produce less energy in the long run, but they can move faster in the short run. Then one of the things that people do in order to try to obviously build up, in order to try to be able to move more efficiently, move parts of their body more efficiently, is to build up muscle strength. And when the muscles become stronger by use, they become more resistant to fatigue. People who work out often, people who use their muscles a lot, often require rapid bursts of high energy muscle output because they're working out and they need fast energy, or they need energy very quickly. And so therefore, sometimes they'll take dietary supplements like amino acids, which make more muscle cells. Muscle cells are built out of protein, and so therefore taking more protein supplements, generally speaking, people who are good athletes very often will take protein supplements. And protein supplements, one of the things they do is they allow you to build more muscle cells, and they increase energy, of course, just like any other energy-producing nutrients. Many supplements contain something called creatine, which can add to the phosphate ions to regenerate ATPs when there's a lack of oxygen. Remember that ATPs, adenosine triphosphates, are a key element in respiration and in aerobic, respiration with oxygen, aerobic respiration, and so therefore adding ATP, which is adenosine triphosphate, has a phosphorus group, and so in order to make sure that there's a constant supply of ATPs, creatine can increase the ability of phosphate ions so that the body will have plenty of these to make new ATPs when necessary. The skeleton, or the skeletal system, is the bone structure, the structure that supports the body. The muscles control. The skeletal muscles are the things that control the skeleton, causing the body to change shape. So you have the bones themselves. Then you have the bones are in the bottom over here, which are hard and rigid and contain lots of minerals, including calcium and phosphate. And the thing about the bones, obviously, is that they're strong and they give you structure, but they're not very flexible. So in between the bones is where we have our flexibility. In between the bones we have cartilage, which contains glycoproteins and has elastic fibers, but cartilage is a hard substance that's it's kind of plasticky. I think, the best example of cartilage, if you want to know what it feels like, is to take your nose, and the thing in between, the thing that separates the two parts of your nose, at least in the front, is cartilage. In the back, you got an actual bone, but in the front, you got the cartilage. And so it's kind of like, it's hard, but it's plasticky and not quite bone-like. Then you have ligaments. Ligaments are the things that hold the bones together. One bone to another is held by ligaments. And then you have, by the way, the tendons. A tendon, T-E-N-D-O-N, is what holds the muscle to the bone. So these are made up of collagen fibers, and they don't have a significant amount of elastic fibers. Ligaments are not that flexible. So in between two bones, there's not necessarily a tremendous amount of flexibility. It really depends on the bone itself. You have the endoskeleton, which is the internal skeleton found in a vertebrate. In humans, for example, we have an endoskeleton, which means we've got a skeleton inside our body. There are some animals, like insects, that have exoskeletons, which means their skeleton is actually outside their body. So our skeleton, our vertebrate skeleton, in other words, a skeleton found on a vertebrate, which means an animal with a backbone, like a human being, for example, has an axial skeleton, which contains the head, the vertebral column, namely the backbone, the rib cage, and obviously you don't want the axial bones to be weak, and then you have the appendicular skeleton, which means like the side skeleton, the pectoral and pelvic girdles, which are lower in the body, like in the midsection of the body, the forelimbs, which are the arms and legs, and the arms and hands, then the hind limbs, which are the legs and feet. If you want a little diagram, here's a little diagram. We've got the whole skeleton here, including you can see the skeleton face over here. The blue is the axial skeleton, and the brown is the appendicular skeleton. As you can see, the blue skeleton is kind of the main skeleton, the central skeleton, and then everything else, the rib cage over here, which protects the heart and the lungs, the spinal cord, the backbone, which protects the spinal cord, and of course the skeleton, which protects the face and the brain. And then you have the appendicular skeleton, which is the arms, legs, pelvis, etc., the rest of the skeleton. Okay. So now let's take a look at some of the parts of the skeletal system. First, we discussed a little bit before the cartilage, which is the hard plasticky material that kind of coats the bones and does some other functions. Some examples of cartilage are the entire skeleton of sharks. Sharks are examples of what are called cartilage fish. Sharks don't have bones. They have cartilage, which obviously can be pretty hard. Cartilage covers the end of bones at the joints, kind of to make sure that the bones don't rub up against each other. In fact, when the cartilage does get worn away and the bones do rub up against each other, which can be very painful since there are nerves there as well, that's sometimes known as arthritis, which is an inflammation of the joints. Arth means joint, and joint means in between the bones. So that's arthritis. So cartilage supports flexible portions of your body, like your ear and your nose. The nose I gave you before as an example. The ear, underneath the skin of the ear, is also cartilage. And it also provides a framework for the respiratory system, the larynx, the trachea, the bronchi in the respiratory system. Cartilage doesn't have blood vessels in and of itself. And therefore, that's why damage to cartilage, which very often causes arthritis, tends to heal very slowly because of the lack of blood vessels that are over there. Lower back injuries sometimes are to cartilage as well. And that's what causes them to heal slowly. There just isn't enough blood there to bring the oxygen that are necessary for the repairing the tissue. Then you have the joints. The joints are parts of the skeleton where the bones meet with each other, located at the elbows, knees, fingers, and they can move. The regular joints, hinge joints, can move forward, or basically they can't move all over the place. They can move from flat to moving in and out. I mean, if you want to know what I mean, just look at your elbow. Your elbow can be flat, where your whole arm is flat from one point to another, or your elbow can move upwards like a hinge. Then you got the ball and socket joints. The ball and socket joints, where the round end of one bone fits into the hollow depression of another. The classic example there is your shoulder. If you hold your shoulder, you realize your arm can't go completely around in 180 degree in a 360, but it has a lot of freedom to move around in your shoulder joint. Then you got the knee joint. The knee joint needs to be a hinge joint, because otherwise there would be decreased stability. If you would be a ball and socket joint, then your knee would be able to move in any direction. You wouldn't have very much stability. It would be very hard to stand up, very hard to balance. And one thing that very often gets injured, actually, the anterior cruciate ligament, the ACL, is one of the major knee joints, and damage to this ligament is very common in athletes because athletes put a tremendous amount of stress in the muscles in their feet and knees and lower bodies. So an ACL tear is very often a sports-related injury, but can also result in other types of injuries. And when a person has a torn ACL, a torn anterior cruciate ligament, it's much more difficult for the skeletal structure to maintain stability. Here are some examples of knee joints over here. And again, you don't have to remember all of these terms, but this is your knee. You've got the fibula over here, which is underneath the bone, the tibia, which is further down, much closer to the ankle. You've got the kneecap over here, the tendon. These are muscles, so the tendon attaches the muscle over here to the bone over here. The cartilage in between in between the bones. Here's a bone, and in between the cartilage covers up the joint. Okay, and finally we've got the issue of bone strength. Bone strength is increased given with weight-bearing exercises. You lift weights or you do anything that could increase bone strength, just like any other kind of exercise. When you increase resistance on something, that tends to build up the strength. Many people hope they will one day be able to go into space. I mean, well, I don't know if that people hope necessarily, but the idea of being in space, or being anywhere without gravity, which is really just in space, is that if you are in space, like astronauts, they go up to the space station for a few months, or they go to the moon, or whatever it is, or even just for a few days, the muscle and bone mass are no longer being used. When you're on Earth, your muscles and bones are constantly fighting against gravity, and therefore maintaining their strength, or even building your strength. Whereas if you're under weightless conditions, there is no pull of gravity, and so therefore the bones kind of atrophy away. Atrophy means to lose strength because they're not used and not needed. So what astronauts do is they do special weight-bearing exercises each day in order to try to maintain their bone strength. If they don't, then they'll atrophy away, they'll deteriorate away, which will cause a serious problem for them when they get back to Earth. Okay, let's take a look at a couple of multiple choice questions. Again, you can pause it and see if you know the answers. Okay. In a muscle that is resistant to fatigue, such as a marathon runner leg muscle, you would expect if it's resistant to fatigue, it means it can produce all the energy it needs. Now, something that can produce all the energy it needs, you would expect it to have a lot of ATPs. A limited blood supply would cause it to be fatigued. A very few mitochondria would cause it to be fatigued. It wasn't not producing enough energy. An ostriated appearance wouldn't work either. That's not a normal thing. The best thing would be elevated levels of ATP. What might be a major disadvantage of a ball and socket joint rather than a hinge joint in a human knee? Well, not decreased strength. That's not a problem. The ball and socket joints are just as strong. Reduced ability to move. On the contrary, it would increase the ability to move your lower leg. Decreased joint flexibility. Again, that's not true because it would increase your flexibility, but it would decrease your stability. It would make it more difficult for the body to hold firm, and so therefore D is the best answer over here. Okay, that's basically what we have for the material. I do also at the end want to go over a couple of essay questions that you might see on the exam, from the exam bank. Just in general, you're not going to see these particular questions, but these are some examples. How would you do this one? Explain how unsaturated fat is structurally different from saturated fat. You know, if you want to pause the recording and see how you would answer that, you're welcome to do so. Well, the way I would answer it is that unsaturated fat, first of all, is liquid at room temperature, as opposed to saturated fat is at solid at room temperature. But unsaturated fat doesn't have all the bonds within the lipid molecule bonded to a carbon, whereas saturated fat does have every single free bond is attached to a carbon. Number 2, normally a certain enzyme has a maximum activity of 37 Celsius, but once it's been heated to 100 Celsius and then cooled back down to 37, the enzyme is no longer active. Why? Well, the reason for that is because once it gets up to 100, it could cause a change in shape or a change in structure of that enzyme. And once that enzyme has been changed, like melted or changed form for whatever reason, it can't go back to the lock and key model. Remember, enzymes have to be in a certain shape in order to act on a particular substrate. Number 3, you're a forensic biologist who's been asked to review the files of an old unsolved murder case. The autopsy report's missing a lot of information, but you read that the victim had a thymus gland that was just starting to shrink. Based on the information, what would you conclude about the victim? Well, if you remember, the thymus gland, which is located near the heart and the lungs, was a key organ in the immune system. So it produces T cells. T cells actually are produced and mature in the thymus. So you might conclude that the victim over here, had a reduced immunity to pathogens, reduced immunity to outside diseases or other forces outside the body. You might also conclude that the victim had some kind of a disease that caused problems for the victim's immunity system. Or immune system. Okay, so that's about all we have. I think you definitely have enough information to do well on the Introduction to Life Processes exam. If you'd like to contact us, please feel free to do so. There's contact information in the course syllabus, and good luck.